Good morning. My name is Vishnuvardhan. I am from Electrical and Electronics Engineering. My power electronics tech talk topic is a forced communication method of solid state transfer switch in the uninterrupted power supply applications. In uninterrupted power supply applications, a solid state transfer switch is a crucial component that allows seamless switching between different power sources, typically between the utility power and an alternative power source such as battery or a generator. Forced communication is a technique used in power electronics to control the switch of power semiconductor devices such as transistor or insulated gate bipolar transistor in order to ensure a smooth and reliable transfer of power. Here are basic overview of the forced communication method in the context of a solid state transfer switch in the UPS application. Solid state transfer switch. In a UPS system, the SSTS is responsible for routing the power supply from the input source to the output load. Power semiconductor devices. The solid state transfer switch typically uses power semiconductor devices like transistor or IGBTs. These devices are capable of handling high voltages and currents and can be controlled to switch between conducting and non-conducting states. Communication is the process of turning off a conducting semiconductor device. Forced communication involves actively forcing the device to turn off by applying specific control control signal. Methods of forced commutation. A gate turn off thyristor, integrated gate commutator thyristor, IGBTs with active commutation. GTOS are thyristors that can be turned off by applying a negative voltage to their gate terminal. Forced commutation in GTOs involves actively turning off the device by controlling the gate voltage. IGTs are the another type of thyristors with integrated gate commutation capability. This can be turned this can be this can be turned off by applying a reverse voltage to the gate terminals. Insulated gate transistors can also be used in forced commutation schemes. Active commutation methods may involve the use of additional circuitry or components to turn off the IGBT when required. Control circuitry. The control circuitry of the SSTS plays a critical role in implementing forced commutation. It monitors the status of the power sources, detects the need for a transfer, and applies the necessary signal to the semiconductor devices for commutation. Benefits of forced commutation. Forced commutation helps in reducing switching losses, minimizing voltage spikes, and ensuring a controlled and reliable transfer between power sources. Protection mechanisms. The SSTS should incorporate protection mechanisms to prevent faults and ensure the safety of the system. This may include overcurrent protection, overvoltage protection, and fault detection. Communication and monitoring. Modern UPS systems often include communication and monitoring features to provide real-time information about the status of the power source, load, and the overall system health. Types of solid state transfer switches. State transfer switches, automatic transfer switch. In and state transfer switch, solid state devices like thyristors or IGBTs are used to switch between power sources. The STS operates without any mechanical components, providing a faster response time compared to the traditional electromechanical switches. Automatic transfer switch. An automatic transfer switch is typically used in standby power system. It monitors the primary power source automatically, switches to the backup source when it detects a failure or irregularity in the primary power. Forced commutation technique. Line commutation. In this method, the current flowing through the device is naturally commutated to zero by the natural commutation process. This is often used in conjunction with external circuits that facilitate the commutation process. Load commutation. Here, the load itself is used to facilitate the commutation process. The load characteristics are manipulated to force the current to zero, allowing for the turn off of the semiconductor device. Gate terms of Gate turn-off thyristor. Gate turn-off thyristor widely used in force commutation applications. They can be turned off by applying a negative voltage to their gate terminals. GTOs offer good controllability and are suitable for high power applications. Integrated gate commuted thyristor. IGCTs combine the characteristics of both thyristors and IGBTs. They have integrated gate commutation capability, allowing for controlled turn-offs. IGCTs are often employed in high-power applications where fast and reliable commutation is essential. Protection and fault handling. Overcurrent protection. SSTS should be equipped with overcurrent protection to safeguard against excessive current in the event of a fault or overload. Overvoltage protection. Protection mechanisms are crucial to prevent damage from voltage spikes during switch operation. Fault detection. Advanced fault detection algorithms are employed to identify and isolate faults promptly, ensuring the reliability of the power transfer process. Control strategies. Proactive transfer load synchronization. The SSTS can be designed to initiate a transfer to the alternate power source based on predictive algorithm anticipating potential power source failure. SSTS should synchronize the power source before making a transfer to avoid disturbances to sensitive equipment connected to the UPS. Communication, communication and monitoring. UPS system often include communication interfaces for remote monitoring and control. This allows operators to monitor the status of the system and receive alters in case of an anomaly. System may log operational data, facilitating analysis and optimizing of the power transfer process over time. Efficiency consideration. Minimizing losses. The forced commutation methods aims to minimize losses during the switch process, ensuring efficient power transfer and utilization of the available power sources. Thermal management. Effective thermal management is crucial to prevent overheating of semiconductor devices, maintaining their reliability and longevity. Integration with energy storage. Some UPS systems integrate energy storage solutions such as battery or supercapacitor. These components play a role in providing power during the transfer and ensuring continuity of supply. Future trends. Ongoing research focuses on enhancing the efficiency and reliability of solid state transfer switches, exploring new semiconductor materials, and advanced control algorithm. Conclusion. Solid state transfer switches force combination play a virtual role in ensuring uninterrupted power supply. Advances in semiconductor technologies, control strategies, and fault handling mechanisms continue to improve the performance and reliability of UPS systems, meeting the demand of critical applications in various industries. Thank you.